Hi, my name is Daniel Yules, and I will be applying the Battle of the Sexes game in game theory to two friends deciding where to spend their gap year. The Battle of the Sexes game form is a two-player coordination game where the players have conflicting destination preferences but both agree that they would rather holiday together. Miles would rather travel to Australia and dive the Great Barrier Reef, whereas Ted prefers to venture to Thailand and volunteer with elephants. Despite having different ideas of the perfect gap year, Miles and Ted agree that they want to travel together. Thus, this game is of the Battle of the Sexes form. By displaying the two friends' preferences in a normal form game, we can see the dilemma. As Miles would prefer to travel to Australia, his payoff is higher from this destination, 3 utils compared to 0. However, if he was to choose Australia and Ted choose Thailand as he prefers, Miles would gain no utility. Similarly, as Ted would prefer to travel to Thailand, his payoff is higher from this destination. However, if he was to choose Thailand and Ted choose Australia as he prefers, Ted would gain no utility. In this simultaneous game, neither player knows which the other will book, as there is imperfect information. As such, we must examine which destination Miles and Ted should book. When examining pure strategies, each individual will seek to choose the destination that yields them the highest possible utility regardless of what the other chooses. Such a process is called iterated dominance and will yield pure strategy Nash equilibria. The decision process works as follows. For Miles, when he takes it as given that Ted will choose Australia, Miles should also book Australia as this yields him a greater utility of 3 compared to Thailand with 0 utility. Let's mark this point. By the same logic, taking Ted booking Thailand as given, Miles should also book Thailand, as this yields him a greater utility of 2 compared to Australia with 0 utility. Let's also mark this point. By applying the same method of fixing Miles's decisions, we can determine which action Ted will take to maximise his utility and mark these. As iterated dominance shows, there are two pure strategy Nash equilibrium, when we cannot determine with certainty which will be observed. As such, we now investigate a mixed strategy. Now turning to mixed strategy Nash equilibrium, we investigate with which probability each player should choose to randomly book each destination. Assuming Ted chooses Australia with probability Q and Thailand with probability 1 minus Q, we can determine how Miles should choose to book between the two destinations by using his indifference condition. The utility of Australia equals the utility of Thailand. By solving this condition, we find that Ted books Australia with probability 0.4 and Thailand with probability 0.6, which makes intuitive sense as Ted prefers Thailand. By applying the same probability and indifference logic, we can deduce that Miles books Australia with probability 0.6 and Thailand with probability 0.4, again making intuitive sense. We then confirm that the mixed strategy Nash equilibrium is 0.6, 0.4. From this analysis, both Miles and Ted should book their gap year destination using pure strategies, as even booking their least favoured destination and the other booking their favoured results in higher utility for both when compared to employing mixed strategies. In reality, this game is unlikely to be sequential and not simultaneous, i.e., one person makes a decision, informs the other, and they decide what to book, rather than both booking at exactly the same time with no communication. If the game is adapted to be sequential, one has to try to choose first in order to attract one's partner towards the equilibrium which is most favourable to themselves. As such, to gain their highest possible utility, Miles or Ted must be the first to book their gap year, as by doing so, they will travel to their most favoured destination.